So this is the PowerMac G5 over here. Okay. This is Apple's professional desktop. It's called PowerMac G5 now. Maybe it's called something else later. I'm not sure. But right now we call it the PowerMac G5. Okay. So this gives a researcher 3 benefits: quad-core performance, PCI Express architecture, and workstation graphics. So let's look at one by one. Why we call it quad-core performance? Previous model G5, we had 2 processors in every box. Okay, so that we call dual processor. Now the previous PowerPC G5 processor had 1 core. There's 1 bit in there that does the calculations. There's 1 bit in there that speeds up certain calculations. Let's say, for instance, if you are encoding video or doing Gaussian blur in Photoshop, this bit, the velocity engine, speeds up that particular computation. And 1512 L2 cache. Now, Apple took this chip, they double the cache from 1 meg from 512 to 2 meg. Not only that, they put in another execution core. So now, 1 chip has got 2 cores, the cache is double and quadruple. Okay? Dual core PowerPC G5, 2.0 and 2.3 gigahertz G5. They use this. But for Big Mama over here, not enough. This is supposed to be the flagship after all. So what did we do? Kali dual. So there's 4 execution cores, total of 4 meg of cache. Okay, and this is the theoretical peak performance that you get. This is called the PowerMac G5 Quad. Optimized for quad-core processing because of macOS 10. Why? The G5 is 64-bit. What benefits does that offer you? Instruction sets can be, you can process longer instruction sets, but the biggest benefit is, okay, we'll talk about that in a minute. I'll just show you the benchmarks, okay, compared to the previous. Okay, it's no point if you have a very powerful engine, but the rest of the thing is not upgraded. This one JPJ kau cakap kan, jangan buat engine evolution dalam wajah tu, tak bagus. Okay, so what happens when actually people do that? They beli Proton second hand 5,000 ringgit, bawa engine daripada half cut, tekan minyak, first time langgar dinding. Itulah jadinya. Because the brake, the suspension, transmission, everything is not being upgraded to suit. So when Apple put in the quad core, they know if they don't upgrade the rest of the component, it's just not going to do the job. So what they did is they put in a dual directional frontside bus. Okay. They put in things like DDR2 Memory, 533 MHz. And this is one of the benefits for going G5. G5 is 64-bit, can address much more memory. And you, if you are doing research on statistics, siapa pernah guna SPSS kat sini? Okay? So if you use SPSS, you know that you get a great performance benefit if you can put as much information as possible in the RAM. You got 16 gig of RAM here. Okay? I like to see one of the lawyer computer fight with that. Okay? And we give you PCI Express Graphics. Banyak orang menyumpah, why did Apple do this? PCI Express Graphics is much better than the previous standard of PCI. Because we have up to 16 lane. We call it 16 lane. Okay? That is double that of the 133 MHz PCI X slot. Okay? And you can do cool things with PCI Express cards. Okay? You can put in very fast graphics cards for one thing, which I'm going to talk a little while later. Now, every one of these PowerMac G5s, we give you 2 Gigabit Ethernet ports. And one of the reasons why we give you 2 Gigabit Ethernet ports is so that it can be part of a SAN. Okay? A SAN file system can have something, you can max out one SAN file system, what was it, like 2 petabytes? Okay, you can have a SAN file system with 2 petabytes of storage. That should be enough for all your MP3s. Okay. Now, SuperDrive. Okay. So we have a SuperDrive for you to burn data into the DVD. Okay. We have serial ATA storage up to 2 times 500 gigabyte hard disk drives. Okay. We have a lot of connectivity, plenty of expansion. I'm just going to skip through all these because I want to get through the graphics cards really fast. Okay. This is what the back looks like. Some people say the back of Apple computer look better than the front of most other computers. Okay. Okay. Internal extension is very easy to open. Let me just move this a bit. Okay. So this is how I open it. Okay. Very easy to open. You can come and have a closer look later. Okay. It's very easy. And just to make sure that things don't go missing, there's a little latch at the back that you can use to padlock the system. Don't tell anyone, sorry. So easy open side panel with 1 bay for the SuperDrive, 2 serial ATA hard drive that you don't have to use a screwdriver to take out. All the 4 PCI Express slots here can be full length cards. Okay? So you're not using very short cards. It's full length. Alright? And we have 8 DIMM slots. This is how you get 16 gigabyte of memory. 8 times 2. And the PowerMac G5 processor. These are the specs. This is why these are so cool. This is why I didn't want to talk about iMac or PowerBook or MacBook or Mac Mini, the graphics. Okay. We have 4 new NVIDIA graphics cards, and one of them can support 2 of these displays at the same time. And because you are using PCI Express slots, you can put a total of 4 cards in there, and each of them can support 2 displays. So this is the one that is the standard. Okay. This one is nice because when you put in this card, they give you one stereo graphics port here. So kalau you pakai stereo goggles in conjunction with an emitter, you get 3D visualization capability from the card. Okay. So instead of having to look at this, you get this. Okay. This is the speed comparison. Okay, 30-inch, that's a 30-inch display. I've got 3 applications running there. One is DICOM viewer. In fact, 2 of them are DICOM viewers. One is molecular visualization. So it's nice to be able to fit them all over there. Right? You can have a single card drive 2 displays, or you can have 8 drive 4 displays. And that's not the end. In the US, they have, this one is Ocean Research Institute. So they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 displays. Okay. And then, if you thought that was good, this is a team that developed Hyperwall. What is Hyperwall? That's Hyperwall. Each one of the displays is 30 inches. Maybe this one will give you the idea better. That's how big it is. This is something nice to put in MVC for you. Okay. Anyway, watching movies on this will be very good. Okay. So that every 8 displays is being driven by 1 PowerMac. Okay. And recently I was informed this actually went to World Book of Records, Guinness Book of Records. Okay. Application performance. Okay, final cut. I think I'm missing a couple of slides. Yeah, this is what I wanted. So, quad-core processing with 4 velocity engine units and 8 floating point units to accelerate scientific analysis. So, in one workstation, you have a very, very powerful processing capability like that. You can have up to 16 gigabyte of memory. You can have a graphic card that can do stereo graphics visualization. And you can run all the Unix programs that you're used to running on the previous systems that you were using. Okay? This is what the stereo graphics goggles looks like. But you have to use it with a CRT. It doesn't work with a flat panel display. But since you can put 2 displays to every computer, one can be a CRT, one can be a flat panel, and use the CRT for visualization and the flat panel for anything else. Okay, Xcode, this is the application program that we give you in order to help you develop programs. It's actually an IDE. And this is Mathematica, how much faster it is. And this is the bioinformatics benchmark, how much faster it is. Okay. So these are the 3 configurations. Of course, please contact the representative from Apple. Okay, so that's the PowerMac G5 Quad and the PowerMac G5 Dual. Okay, now we get into the interesting part, which is the applications themselves. Again, I have to tell you that I am not a scientist, so I will make mistakes and I apologize in advance. Okay, but anyway, let's have a look at what a 9 scientist can do. We're going to run a program called OsiriX. Okay, this is actually a very, very unique program. Okay, who knows what is meant by DICOM? Do you know what's a DICOM image? I know Dr. Zainal knows, and I hope he won't say anything. If I'm not mistaken, it stands for Digital Images and Communication in medicine. Okay, basically, an X-ray can be considered a DICOM image. Okay, so in hospitals in the US, they would have a central server where they would load patient data. Okay, this is called a PACS system. I can't remember what PACS stands for at the moment. Anybody want to help me? PACS. Okay. Anybody remember? I can't remember. So anyway, the theory is a doctor wants to review somebody's case. He opens a software. He goes to a specialized terminal called a PACS viewer. Okay. And then he can click on the patient and he can see everything to do with the patient CAT scan, the patient MRI, the patient PET scan, and so on. So there are 2 doctors in the US that thought this is something that can be done by a Mac, because both of them are programmers and the Mac comes with a free development environment, and the Mac comes with a rich set of Unix tools that they can use. And it also comes with OpenGL graphics, which they can use to render the graphics on screen. So they developed this program and they call it OsiriX. In part, it's based on the OsiriX DICOM viewer. And this is the result. So this is a patient right here. And you can see that there is 2 series of images. This is a CT scan, right? And this is the PET scan. Okay, when I go back, you can see that it's actually scrolling through all the CT scan, and you can also scroll through all the PET scan images. Now this is not terribly helpful to me. I want to see both this and this at the same time. So I press Apple and click, and then search on 2D, 3D viewer. Okay? Now, this is a non-trivial task. This is a sequence of pictures. This is also a sequence of pictures. But what OsiriX does is that every picture here matches every picture here. So when I animate them, okay, so you can see this is the CT and this is the PET for the same. But maybe that's not good enough. So I'm going to change this PT scan. I'm going to give it this black body lookup table, and I'm going to drag this over here, so we can do fusion. So nampak, the image is superimposed on one another. Okay. Now if this is obscuring, you can change the transparency. typically this kind of functionality will cost thousands and thousands of dollars in a full-on professional PAX workstation. But here, the program is free. Amazing. And that's not all that you can do. I'm going to switch to orthogonal MBR. So now you can see, okay, you can see this is the cat, this is the pad, and this is the combined view. Okay. Alright. Now let's close this, and I'll show you something else that you can get as a cool feature. You can do 3D surface rendering. So that means I click on that, and I'm going to click just one surface for now. It will take the CT data and it will create a 3D OpenGL object, which you can rotate. Okay, nampak sangat tak rotak. Okay, rotate, zoom, left, right, go back to actual. Okay, and then zoom in. But let's say I don't want that. I want both the pad and the CT data. So I go again to the 3D, I go 3D surface rendering, and this time I put a second surface and I make that surface transparent. Now this is where the G5 really shows its computational power. Because if you do this on your Laoyat computer, it'll take a lot longer than what the G5 can do. Alright? So you can see, fully OpenGL, nampak, you can see this is probably a guy because that's his nose. You can see his nose there. Okay. Alright. Now, you have this, but then you might think, okay, I'm in a teaching situation. How do I get this out so that my student can look at it? Very simple. I just make it a little bit smaller size, and I hit on export QTVR. So let's save it as kepala saya, and we'll put that on the desktop. And we'll just go with the standard defaults for now. You can see that the machine is revving up right now. The bunyi yang terbang tu is actually this computer. Okay. So this is QuickTime Player. You have version of QuickTime Player for Mac and for Windows as well. You can rotate, you can zoom in, you can zoom out as well. Okay, so let's just quit QuickTime Player, quit OsiriX. Now I'm going to run this software called iWeb, which comes free with every Mac as well. And then I want a black, and I want a movie page, and I click on choose. Okay. Kepala saya. Sila lihat gambar ini atau ni image ini 3D ini dan buat laporan. Let's just drag this in. Yeah, so what? Okay. So that has been added, and now I'm going to save it as a folder on my hard disk. Website saya. Website saya. And this is the HTML. I just drag this to a browser. Okay. So that is how I publish my work to the internet. I can do assignments this way. Okay. Very, very simple. Alright, so we're going to look at another program. Which is called Neurolens. This again is open source. It's totally free. Doesn't cost you anything. And I have some DICOM series as well, which I'm going to drag over to Neurolens. Okay. This is for doing fMRI analysis. Don't ask me what is fMRI because I don't know. Alright? But again, you can view a DICOM image. Okay. Whichever part of my brain that you want to see, you can view it. Okay. You can increase the size of the resolution. You can change the color space. Okay. And you can change the level to make things more clear. Right? And if you are not happy to see this one slice, you can show all slices. That shows every one of the slices. Okay. Axial, sagittal, coronal, and plot. Plot is interesting because plot is a dimension based over time. Okay. So that's Neurolens. Again, it's free. Doesn't cost you anything. And the last application that I'm going to show you is PyMOL. Again, this is free if you're a student. You can use it without any restrictions. So you do molecular representation in PyMOL. Okay. So we go and choose demo. These are the representations that PyMOL support. Okay. Again, you can zoom in, you can zoom out, you can rotate, you can do whatever you like with it. Okay. I think if I show cartoon ribbons, I can show you better. Okay. So I can drag it about, I can zoom in and zoom out. Okay. I can rotate. And PyMOL supports stereographic glasses. So if you buy the stereographic goggles, you can actually look at that. Okay, now another thing is very interesting that I want to show you is sculpting. Okay, this is something, a molecule, but let me show you what this can do, because to me, I find it very cool. Of course, if you're a scientist, you probably figure out the things, but to me, I think it's just cool. This is good for something, I just don't know what. Okay, but you can see when I pull on this, you can see that it behaves the way a real molecule might expect to behave. Okay, so it would help when you want to do the teaching. And if you have a video or an animation, say for instance this is a simple animation, you can actually create a movie out of it. Where is it? Okay. So again, I save it as a PyMOL movie. Let's put that on the desktop. Save that. Right. And this is the movie file. Cool. And again, all I need to do to put it up online is go to my web. Right. So I do another page. Again, this is a movie file. And this is a molecule study. Drag and drop. I don't know what this is about, but it looks cool. Okay. Publish to a folder, or publish to your website, or put it on your web page. Open up the website. There we go. This is the first movie, this is the second movie. You can play the movie. Okay. And you can also do this in episodic or block format. Okay. So I just do block, or in this case a podcast. Right. So you can see this is one entry. I'll put in the first movie. So I add a second entry and I'll put in the second movie. Yeah, so on. Okay. And let's publish this. Okay. So let's see what that looks like. Okay, we go to podcast. So this was the first episode, and this was the next episode. So you can do like every assignment, you can put in this format, so the student can go from his first assignment to his last assignment, and they can go back. Very easy for you to do. Okay, so that is PowerMac G5. So we will have a break now.